Hello, everyone. My name is Jin. As Micah graciously introduced, I am one of the co-founders here, and we've been thinking and designing Saga for a while now internally, and um, we recently with a lot of the new folks coming in, kind of with our launch and with launch pool and such. As mentioned last week, we kickstarted the Stack Exploder kind of Twitter Spaces series, so new folks can come in and recap and learn a little bit more about kind of what the original design was and where we were going, and just kind of learn a little bit more about the details of Saga. And so today we're gonna dive just a little bit into the economic flows, but there's the economic flows is a topic within this space that's pretty deep, and I'm gonna say that a lot of the time within Web3, at least, there's a lot of kind of talk and celebration of cool technology, which Saga has as well. But most of the time, kind of innovations and improvements in economic flows are not celebrated publicly or even privately, really. And so today I kind of want to focus a little bit more about this, kind of talk about the history of various economic flow systems within crypto, and talk about how Saga kind of thinks about it in a slightly different way and innovates in this space. And so that's going to be kind of the high level topic for today.
I kind of love that. Yeah, this is a great space series, and honestly, it's a spot for everyone to learn. I want to note for everybody who's on this call that we've had requests in the past to make sure that we explain it like I'm five, because obviously Jin is deep in the weeds of building Saga itself, building the systems, and I will play kind of. I'll play layman here for you and try and translate some things where I can, or also just ask follow-up questions. So if we're getting into the middle of something and you're really fascinated by what you're hearing, but maybe you need a double click into it, I'm watching Discord as we're on this call, and obviously the responses to our actual announcement tweet here. So if you have follow-up questions, I'll try and make sure I get clarity as we go along. Also, this is kind of our week two into a little bit of uh, history lesson in crypto to go along with how we got to where we are today. So uh, I'm excited about that. I think that we're going to kind of take this same a little bit of history approach to it. I think that where we want to start off is, I don't know how we transition to this, Jin. Scarcity centric design. How do we even start talking? Can you give us an overview a little bit? Because I think that we want to start here talking about scarcity in the space. It's something we hear about all the time, but let's break this down before I think we double click into scarcity centric blockchain
Yeah.
design.
So um, if you go start from the very beginning and think about like what the original design for how economic systems work in blockchains. Um, this is not. I don't know if this is a real term. I just kind of made it up on the spot as I was thinking about the topics for this Stack Exploder. But all all of the design elements for the economics for blockchain so far has been what I call scarcity centric design, which means well, what do I mean by that? It means that there is something within the system that is scarce. It could be block space, it could be something else, but something essentially is valuable, right? And there's not enough of. And what you do is you design an economic system in which people or various stakeholders within the system are competing with one another to try to get access to that scarce resource. And let me start with some examples here because this will become a little bit more clear. So let's start with the simplest, right? The OG Bitcoin, right? So this is what generally we consider a monolithic chain. It's a singular chain, and really block space is what's scarce here. And why is block space scarce? Is because the way that block production works within Bitcoin is there's energy production that needs to happen for computation for block to progress. And so the scarcity essentially comes from the fact that there is a cap on the worldwide energy production, or those people who are using that to compute the Bitcoin block essentially. And so who's competing in this space, right? Ultimately, it's the end users end up competing here, right? So let's say I want to send 5 Bitcoin from me to somebody in this spaces, let's say Jonathan. I'm gonna need to pay.
5 Bitcoin
Yes,
in this
yes,
economy?
5 Bitcoin.
Okay.
It's a big bonus day for Jonathan, and and so sorry, I thought we were talking about history lessons here, and so I figured we might as well go back to historical numbers.
There you go. I love that. Okay.
um, what I need to do is I need to pay kind of extra in paying gas essentially, and compete to get my transaction included in that block, right? So if I'm the only one there, then that's great. That's easy to do. Then there's it's going to be pretty relatively affordable. But if there's 10,000 people or 100,000 people who want to do the same thing, then essentially it becomes an auction process, right? So like I say, oh, I'm willing to bid this much transaction fees, and only the ones who bid enough will get included, right? So this by design is a scarcity centric economic design, right? So there's something scarce, people are competing for it. It's pretty easy to do. There has been like surprisingly very little innovation, and I mentioned this earlier, in economic design in blockchain. This kind of scarcity centric design, economic design, is very hard to escape from actually, because it actually runs the design of how you can design an economic system usually runs in tandem with these really cool technical designs that you are doing, and by kind by default, blockchain is there's not an infinite amount of block space for people. So in essence, it's actually really hard to escape this kind of scarcity centric design. And I'm going to list some like examples essentially starting now of some folks who actually tried to escape this and ultimately kind of ended up not being successfully so. So I think the biggest example that's at least similar to Bitcoin in the recent past is probably who tried to escape the scarcity centric design was Solana. The reason why I say it's the closest to Bitcoin is it's still a monolithic chain. So by design, it's very similar, right? There's a singular blockchain, and people are competing to get the resources of the blockchain. And so originally, Solana started off with essentially not having a fee market, right? So it's like anybody who can kind of who wants to try to include it. What Solana's design or goal was to make the pipe fatter and fatter until it doesn't matter. It can always support as many transactions as possible, right? And everyone knows that that experiment didn't quite work as expected, right? What ended up happening is there were downtime. People's transactions would just get dropped. Solana, the chain would go down. There's a lot of issues with just opening it up essentially for everybody to come in and try to fill in the pipes essentially. And so I would say that's like one interesting kind of design experiment to try to get away from the scarcity centric design that has failed. And now you see Solana essentially kind of clawing back in, and they're introducing kind of a fee model again, which is the same design ultimately, right? Which is when I say earlier that there has not been much innovation in economic design and blockchain, this is a good example of one where somebody tried to do something outside of the box and kind of was forced back into the scarcity centric design again of gas costs and transaction fees.
We are holding up Solana as having like made pretty significant waves in the experiment. And I think for a lot of us who maybe have participated on the Solana blockchain also, we don't always know what the trade-offs are. It's like, yeah, like that's great, fees are low, but then we go through these periods of congestion where, if you're trying to do something that's actually very heavy lifting and you're having failed transactions, it can be very, very frustrating. But there's also been other experiments in this space too, right? Like we're kind of approaching the same thing, or Polkadot has kind of like tried to take us an approach on this as well, right?
Yeah. And so, um, yeah, thanks for, yeah, we do want to get to how Saga is different, but to really understand that, I'm going to start talking about all these different historical examples and show
Yeah.
how it has
No.
failed. And so we're not going to get to Saga until a very, very long time, until the end of this podcast, essentially. But well, not podcast. I don't know what this is
Okay.
called.
Everybody's strapping. Yeah. Don't worry, there will be no quizzes after this.
So Polkadot is a really interesting example. So I would say of all the other blockchain systems out there, that's relatively large, right? Polkadot is kind of out there and experimented with something that I think is pretty fascinating. What Polkadot said is, okay, we still have a scarce amount of block space, right? What their technology essentially was like their entire system is depended on having these things called parachains, and parachains is kind of similar to like app chains. It's kind of similar to what we call chainlets, but essentially they attempted to kind of get away from this scarcity centric design by shifting who pays for this scarce resource, right? So in Polkadot, what ends up happening is there is a limited amount of kind of parachain slots. So let's say I don't know what the latest number is, but let's say there's 50, right? So essentially, their block space is divided into kind of like these 50 chunks, and they're auctioning off access to this 50 chunks to developers, right? So in this scenario, the interesting thing is they haven't really gotten away from this scarcity-centric design, because fundamentally there's a scarce resource, which is block space, right? And now, instead of having the developer, I mean the end users pay for the gas to pay for that access, they've kind of flipped the model and created kind of an auction model where developers can come, or projects can come essentially, and bid for this access to this parachain, right? So fundamentally, this is a really interesting economic design because it's different, obviously, from just the mere transaction model. However, it still fails to kind of escape the scarcity centric design, and this is because, as mentioned, the way that the technical implementation and the token economic system was designed from ground up is kind of dependent on this like scarce resource ultimately. But the most successful in kind of escaping the scarcity centric design, in my opinion, is Cosmos, right? So for those who don't know, what is Cosmos? Cosmos is just essentially like a app chain framework. It's probably the easiest way to call it. And essentially, every application is supposed to be in independent blockchains from one another. And by doing this, you kind of escape this like scarcity-centric design, right? So in parachains, there's a limited amount of parachain slots. In Solana, in Bitcoin, there's a limited amount of space in the block, essentially. With Cosmos, the interesting thing is like an application essentially just had to go and spin up a new blockchain, and there was new like greenfield block space that was available for anybody to kind of modularly attach to existing blockchains out there, block space out there. And so this is like, I would say, the only real successful non-scarcity centric design economic model was kind of kickstarted by Cosmos and kind of app chains in general. And this is kind of where I want to start, right? So because while it was one of the first attempt at it, in my opinion, it's not. It still has a lot of interesting limitations in my mind that kind of causes its own issues essentially, and also and the funny thing about it is the economic design also has shifted kind of slowly back towards scarcity centric again. And
Me, I think like I've been in this space for like a long time, and I've always assumed, this is just me being a dumb marketing person. I've just always assumed like that is the only thing, that is the only option. Like a scarce model for block space is the only solution there is, that is like part of the inherent, like what is built into the idea of building decentralized systems in general. And so I genuinely am curious. Like obviously I understand the distribution of blockchains on Cosmos is unlocking somewhat of a future here, but I do think we need to kind of like double click into that a little bit more, because without maybe just spending all of the time talking about Cosmos, what are the differentiators there? Like I said, I there's many in this call who are much smarter than me in this space, but I just always assumed like, oh yeah, block space is always going to be limited, always going to be a fight for it. What other alternatives are there besides like what we're calling kind of this scarce model?
Yeah, yeah. So last week we talked about kind of the technical model of Saga. Like, what is it that we were doing? It's essentially, Saga is a chain to launch chains, right? And so fundamentally, the basis here is that the app chain Cosmos model is the correct model to scale this out, right? And a non-scarcity centric economic design on top of this like app chain model is like what ultimately what we're trying to get to in Saga. And so here's an interesting kind of like zoom into Cosmos. So traditionally, we talked about this kind of last week, but I'll do a quick recap. When somebody wanted to launch their own app chain, what do you have to do, right? You have to go and create a staking token, right? You need to go and create economic system that accrues value to that staking token. You need to go and convince a set of validators, right, that your token is worth kind of operating and running. You need to convince a group of people out in the world that your staking token is worth staking. And then, and that's it. You know, obviously you have to actually write your app chain, which is a whole set of other things. But let's say that's already done. Let's technically say that that's the easiest part about this whole thing. There's all these other things that you have to do essentially to get a app chain rolling, essentially. And this is essentially kind of the funny thing about this is, I would say in a utopia where there isn't like these restrictions on what things needs to be done, the app chain model is like perfect, right? Because you're hello, sorry.
Yeah, no. I'm agreeing with you. Like, yeah, you're building out space as you go along.
Yeah, it's perfect, right? But
whenever necessary, yeah,
exactly. But like in practicality, what ends up happening is you still kind of end up getting sucked back into this scarcity centric design. And how do I mean by that, right? Like, by having that necessary step of needing to convince individual validators or groups of validators, as well as end users whose attentions is limited, your economic design kind of becomes scarce again. And this is no longer technically scarce. There's no nothing that says you can't add new blockchains, but what the reality of in my mind, what has happened over the years is that when someone tries to launch a new app chain, there's only a certain number of app chains yet that like the community can kind of hold in their head and support, right? And validators, there's a limited amount of attention that the validators have to try to focus onto a specific app chain, for example, to support that and launch it and coordinate, upgrading and be a participant in, because all these app chains obviously have governance as well, and there's like there's only a certain limited amount of like attention that people has. And so ultimately the funny thing about Cosmos is like it's still scarce. It's just like scarce like one level further away, right? And the funny thing about Cosmos also is the hub, essentially Atom, adopted a kind of a Polkadot-esque kind of shared security model, essentially. And obviously this process is reintroducing scarcity back into the place, because the way that the Cosmos shared security, we talked about this a little bit last week, is it's governance gated, right? So validators essentially of the system needs to vote and need to approve of running this like second chain, essentially. That's the way that the Cosmos method works. And by needing to convince essentially a governance and the participants of the chain, you're introducing essentially scarce elements into your blockchain again, into your economic system again, which is like, as I said, escaping this is really, really difficult. It really requires kind of like a fundamental rebuilding of what's blockchain today, essentially, for someone to actually fully escape out of this scarcity centric design.
Okay, so I'm ready to kind of take our like, hey, light bulb moment. Here's something that everybody should probably note here. So what we've talked about so far is the idea that within the design of monolithic blockchains, scarcity is built in. And ultimately, I think it is important for all of us to consider like what a maybe like perspective for Saga is. We are, again, very, very focused, and we believe in a future where there is another billion, 2 billion people interacting in the crypto and on decentralized platforms. But the way that monolithic blockchains work today, there are just inherently the scarcity of space in the block space. No matter what, will make it more expensive for the end user. Will no matter what create kind of denser and denser transactions. And obviously, different blockchains are trying to solve this in different ways through roll-ups or through the design solutions that Solana is introducing. But it's almost impossible to escape this idea that as more adoption happens, this will continually become a more crowded space, and block space will just evaporate under the pressure of new users here. Now, we believe that Cosmos is tapping into something a little bit more clearly here. The idea of just spinning up more chains to deal with this or to accommodate more users coming in, more block space being taken up by transactions, is a way to fight against that constant pressure of scarcity. You essentially, this is why we have this idea that we are an L1 to launch L1s, because being able to scale elastically as more people come into a specific app or into a specific ecosystem is the way to eliminate that density and that scarcity of design. But there's an issue because the way it exists today within something like Cosmos, and I think this is a light bulb moment, is like it is not permissionless. So while the actual technicality of just being able to create a new app chain is simple, the way that Cosmos is designed at its heart is still trapped under the weight of these validators having to approve every single new chain that is created or app chain that is spun up. So while I think what Jin's trying to say is the technical side, yeah, we create chains in infinity, but most of the other systems designed prior to Saga were still permissioned by the validators, and they still created a system in which now it's just slowed down by the paperwork, realistically, of having to like get the approval of the community for each of these new app chains that spun up. So we've gone from the monolithic chains that actually are going to run out of space and are running out of space, the ones that are trying to find new ways to scale. There's a half solution of creating these individual app chains, but if it's still permissioned, then you're basically just handshaking and pushing off all of that pressure, all of that scarcity, essentially, to maybe a more abstracted layer, I would say, Jin, but still a layer where it's slowing this down, and our ability to scale as an industry is still is kind of like approaching somewhat of an asymptote.
Yeah. It's I would say a more frustrating layer because with gas, it's like you know exactly what the limitations are. You're like, okay, there's a cutoff for how much transaction fees I need to pay to get stuff included. Whether or not you get included as like an app chain that people are willing to listen to and follow and participate in, it's a much softer requirement, right? So it's hard. It's a more difficult thing for a project to kind of suss out in the beginning, right? So I'm gonna like dovetail very quickly into kind of modular, and I think modular is really interesting as well. It's like another attempt at this. It's a similar vein and thought process as app chains and Cosmos. It's like kind of trying to create new block space underneath existing block space, but modular is, and I'll kind of explain this in terms of like kind of like supply chain, which is kind of a weird analogy here. But if any part of your supply chain is scarcity centric, then your entire system becomes scarcity centric. And what do I mean by this, right? This is why it's so difficult to like escape out of the scarcity centric design. In modular, essentially, you're splitting out like block production into like multiple parts, right? So there's like DA, there's like settlement, there's like the details don't really matter. There's like multiple components out there in the world that essentially handle the block generation, right? That's the point of modular. And while if let's say every part of it is non-scarcity driven, which means that it's like, I would consider the opposite as like abundant design essentially. But if one part of that supply chain essentially is still scarcity centric designed, then your entire system becomes scarcity. So like let me pull out an example. So let's say there's a rollup. I'm rolling a rollup that has Celestia DA and it settles on Ethereum. Let's say that's the state of my block space that I created. And let's assume obviously Ethereum is similar to every other chain out there. It's a monolithic chain. So Ethereum, to settle on Ethereum is scarcity design. It's the same way that as Bitcoin, right? Essentially, people are competing to put stuff into that chain. So maybe Celestia can infinitely scale, and maybe every other component can infinitely scale. However, by the time it comes for me to shove my state into Ethereum, that's scarcity centric, which means that that entire design kind of becomes difficult to like scale out essentially. And so I'm trying to set a space here, and the reason why I'm mentioning modular is it's not to dunk on modular. I think modular is really interesting. It's the fact that this kind of scarcity centric design permeates through all the pieces of what you're trying to design, and it becomes difficult if one piece is like external to you, because as soon as any part of the components become scarce, then it's very difficult for the entire system to remain not scarce. Is kind of like the point of this part of the conversation. And so why is it, so people will say like, why is it that scarcity centric design is like a problem? Why is this a problem, right? Maybe it's okay that things are scarce and people are competing. Isn't that basic economics, right? Like that's how the world works. I mean, yes and no, right? So the ultimate problem with scarcity centric design is it causes volatility in expectation essentially. So generally speaking, let's say the simplest example would be Ethereum, right? Let's say today Ethereum costs $3 for me to include a transaction. That's a little high, but still. And tomorrow suddenly it requires $300 to include a transaction. As a person building a decentralized application, it becomes very difficult for me to plan things, right? So what kinds of things kind of manifest from having this like scarcity centric design permeating in your system is that there's ultimately less experimentation, right? Because I can't plan things, I can't do things, which means that less is going to be done essentially. And then obviously this is like the kind of stuff that people always talk about, which is how come mainstream adoption hasn't happened yet? How come mainstream use cases are not here yet in blockchain? It's because of this scarcity centric design, right? So anything that has real use cases just inherently gets filtered out automatically because, as mentioned, you can't plan, and it's too expensive to kind of like try to include those things. And so by default, things that are actually real and global and have use cases automatically get filtered out by any product that's essentially scarcity centric, right? So maybe I'll pause there and then we can go from there essentially.
No, I think it makes sense. I mean, the way I imagine it in my mind is like if you're every day waking up and you go for lunch to grab a sandwich, you expect that sandwich to be, $12.99 every day. But if the price of tomatoes is going from $1 to $12 per tomato, the guy making your sandwich for you is going to not be able to charge you the same amount. So as a user of any product on the internet, typically any digital thing that I interact with, I expect it to function and I expect it to be consistent when I'm like interacting with it. A lot of us who are new to the blockchain space, one of the very first things we have to kind of readjust our expectations around is this idea that, yes, I am always directly competing basically with every other person who's also trying to do something on these blockchains. And so, yes, I love my brothers and sisters in Ethereum, but there's often times where I'm waiting until, the middle of the night for an optimal time when tomatoes, as it were not as expensive, and I can do the transactions I need to do. Again, I think that for many of us who are here, we ultimately just see this as one of the fundamental core components of building decentralized systems. I think the idea that there even is another alternative to this, again, people are trying to eliminate volatility where they can, minimize volatility where they can, create ways to better scale these monolithic blockchains. But yeah, this is a spot where we don't typically think that there's actually a non-scarce way to design a system or provide something that isn't volatile to those who are builders. So hopefully we can kind of like talk a little bit about that.
Yeah. So like, how do you build like a non-scarce or like abundant system, right? So first obviously is there's like a bunch of things you can do. There's no golden rule, as mentioned. The design of the economic system and the technology that you're building on kind of needs to go hand in hand. It's difficult to just say, hey, I'm just gonna stick Ethereum out there and or like a monolithic chain out there and try to tack on a abundant like economic design on top of that. It doesn't work, right? And that's what I meant by like Solana. That's a really good example of a scenario where it just like does not work because the technology underneath is not catching up to essentially the abundance that it's promising essentially. And as soon as that happens, then you kind of run into a lot of these issues, and this will happen over and over again, right? Until your system becomes unabundant again, right? Non-abundant. So there's some guidelines that we can follow. So one is this permissionless thing that was mentioned earlier. So making everything in the system essentially, and making all parts of the system essentially that are manual and or inaccessible, and automating that process and making it permissionless. That's like, I would say, is the number one thing that you can do. So for example, I mentioned economically, Cosmos is something that allows you to get abundant block space, right? But there are things like governance or manual processes like, soliciting validators and other stuff essentially that kind of get in the way, right? So the number one thing obviously is to strip those things away, make it permissionless, make a system in which provisioning kind of new resources that people want is automatic and in the background, and does not really involve human intervention, right? The second thing is more about kind of pricing structure. So once you have this thing that essentially is automatic and permissionless, then you need to price those things as if you have an infinite amount of those, right? And that's kind of the basis of how you get pricing structures that are stable and long-term and actually abundant, right? So like, here's a good example of similar to what was previously mentioned with tomatoes. So if tomatoes can be grown kind of infinitely, or as much as we need it, and tomatoes are available everywhere at all times. However, if you price tomatoes as if they're not available, then that's the example of diamonds essentially, where there is an abundance of something, but there is an artificial restriction of access to it, and you need to obviously cut that away. Design a pricing structure in which things are affordable and commodity pricing essentially. And then the last thing.
This is also, sorry, one like thing is like, that's also like, just again for us and from a meta perspective and from an adoption of the more decentralized systems, we have to like be working towards commodity pricing for all of these things. Like there's very, very few That's just the nature of how things work. As it scales up and becomes a mainstream object, the idea of commodity is that inherently, like if we can build out infinite blockchains and give everyone one, then we shouldn't be pricing this as if they were a scarce item.
Yeah, that's
Correct?
correct. That's exactly right. And that's exactly one of the reasons why it's very hard to see a future in which there's what like quote unquote mainstream use cases kind of coming into Web3, because I kind of talk about this a lot before, but um, before essentially cloud kind of came in and democratized like servers in the world, what developers had to do is they had to go and kind of build their own data centers, right, manually. And the access to building a data center obviously is, that's a difficult task. It's expensive. It's not economically viable for everybody, right? And as mentioned, back in the day before kind of like cloud and like AWS existed, the only kinds of there's like a big differentiation between, there are these like websites that are cheap, that are static, that don't do anything. It's like, people like, Joe Schmo's blog somewhere in the middle of nowhere, right? And there was like crazy high compute things like Netflix kind of sitting next to each other. That's like before pre-cloud essentially. And then post-cloud, like there's all this experimentation. There's new applications popping up every day that's hosted on Amazon, because the access to such abundant compute and data centers was like opened up essentially. And I would always kind of come back to AWS as a really good example of how to create an abundant system, right? Because when you go and you launch kind of like a new server or a new website with AWS, it's relatively cheap. Like a college student can go and like spin up a new like web server, right? And so um um and so um sorry, I like lost the train of my thought. So
Talking about AWS and the analogs to pre-cloud and then post-cloud.
yeah. And so the coming back to the cloud and AWS. So the reason why this model works, right? So the alternative is like customize expensive and scarce economics, and you're like, wait, but if you make everything commodity pricing and you make it available for everybody, like how does value get created essentially? How do you make a system in which it's much more valuable for the system essentially to offer this commodity item for lots and lots of people, right? What you do is you get economies of scale. That's like the third thing I would say that is required for anti-scare systems. What do you mean by that? In economies of scale, the more kind of the more customers or the more people that you sign on into your system, the net cheaper it becomes for like each person. So in blockchain, it's kind of the opposite, right? So let's say I'm on Ethereum and I first have 1,000 systems, 1,000 projects, right, building on it. And then tomorrow I have 10,000 projects building on Ethereum. The economics is such that everyone gets more expensive because everyone's competing with one another, right? This is this scarce centric design. What you want out of this is when you have 10 times the amount of builders, you can essentially make your system more efficient and everyone pays a little bit less. And this is the opposite of how the system works. And that's actually exactly how AWS works, right? So there are hundreds of thousands of customers of AWS. Oh, actually, I don't know what the number is, but there's a lot of customers of AWS. And really, the more customers there are, the more the cheaper it is for everybody, which is like kind of weird if you think about it. How do you design something that's like that completely differently in a blockchain setting? And so that's fundamentally, I would say, the basis of what Saga is and what we're trying to essentially get to. And I know we've kind of took this like very meandering path towards here, but it's a very difficult concept to kind of grasp and think about. And in the very beginning of this conversation, I started by talking about how economic design is not really well celebrated within this ecosystem, and this is why, right? There's so many things to think about that goes into this economic design to be able to essentially design a system in which you get economies of scale, you get predictable pricing, and then you get automation and you get permissionless like deployment, like all that. Like it's very difficult for like one person to grasp. And so this is why I would say like this is kind of the vision that Saga has fundamentally from the ground up, to essentially design something that can function in a very similar fashion. So how does that work, right? So let me kind of go through each of the points that I just mentioned, and then I'll talk about kind of how Saga achieves each one of these, and then maybe we can kind of close it out here today with that, and we'll go a little bit deeper into each of those points next week. So automation, things like governance, our system essentially, as we talked about before in last week, there's no gatekeeper, right? Everything is permissionless, everything is automatic, and our system essentially is like when someone requests a chainlet, all of it is done through software, so there's no human intervention that's required ultimately, right? Predictable and defined pricing structure. So we don't actually set, we don't like really go out and tell people, hey, like we want to extract as much value as possible from your blockchain that we're standing up. We kind of flip it essentially, and we have this auction process that determines the price of a chainlet ultimately. And so this allows the actual pricing to be predictable and commodity. And that's like, we can kind of go deeper into each of these points in the following weeks to talk about exactly how this functions. But that's the second part of Saga's design, essentially, that allows Saga to be a little bit more abundant. And then chainlets have economies of scale, which is really interesting. So the way that we have designed our entire stack is that a chainlet is kind of the same, right? So let's say there's 100 chainlet running on our validators infrastructure. Each of those chainlets are kind of identical to one another. It's like in the current case, it's an EVM based Cosmos chain that is cookie cutter. And so when you take a look at when you have 100 essentially chains, the way that our economics works is each developer is paying kind of like a subscription fee to keep this chain alive. Not all 100 of these chainlets are utilizing 100% of their theoretical maximum amount that they need, essentially. So when in the example of, let's say, 100 chainlets, usually what will happen is like 20 of those chains will use up, kind of the vast majority of your resources, and then 80 of those chains will essentially be doing not much. And so you can essentially start compacting all of the resources that your validators are running in the background, and get economies of scale this way, essentially. And so, by like, think about it this way. Let's say the 80 chainlets that don't have much activity can be shoved into a compute box that's equivalent to one super busy chainlet. Then, in the example that I shared, you can essentially allocate 20 chainlets, right, worth of resources in your validator, and one chainlet worth of resource that 80 of the chainlets are essentially utilizing. And you now essentially are servicing 100 validators using 21 chainlets worth of resources. 100 chainlets using 21 chainlet worth of resources, which kind of gets you that economies of scale ultimately. You can compact this more and more. And over time, that's the design of how Saga functions. You try to shove as many of these kind of chainlets into a small amount of hardware resource as possible, but in a decentralized fashion. And that's kind of the three, I would say, innovations that Saga is bringing that allows our product to be a little bit more abundant and non-scarce ultimately. I know that was a little bit dense, but we'll go deeper into each of these points in future Stack Explorers. But wanted to give essentially a high level summary of why, how essentially we plan to design our economic system a little bit less scarce than what it is today. So.
I think I was intrigued by Saga when I first heard about it because some of these things feel so different than the rest of the space. Being an L1 to launch L1s, making sure that any app can have its own chain. These are almost foreign concepts outside of us talking about it. Sure, there are other chains that are talking about how to create subnets or L2s or these types of things, but ultimately we are putting a stake in the ground saying that we have a system that fundamentally is very, very different than anything being created in the blockchain space today. And not only is it a different system, but it is a system that grows stronger and more powerful the larger and stronger our ecosystem grows. Almost every other chain or ecosystem in this space, more problems are created the larger it grows and the more adoption that it sees. And we've all been in this space long enough for many of us to see now so many of these ecosystems that we fell in love with begin to form cracks once they reach a certain amount of scale. And we are nowhere near the mass adoption that I think we all believe is on the horizon for what decentralized applications and systems will be even 5-10 years from now. So if we're already beginning to see the cracks forming in many of the other even very vibrant ecosystems being built in this space, we tried from the outset to think about scale. Saga is here not for the 85 chainlets and 350 like builders that are here today. It's for the next wave. It is for the 2x, the 3x, the scale that we believe that the blockchain and decentralized systems are going to achieve down the road. That is where our vision is for. And the only way to get there is to make sure that the builders are not suffering from the volatility, that the pricing for building these blockchains is consistent, to be able to say that there's nobody who is standing in your way and having to run the paperwork before you as an app get your own chain. That should be a permissionless system where you just come and you make that request and you are immediately granted your own chainlet to be built with. We think that the idea that these chainlets, as they scale, that we reach these economies of scale, designing our chainlets specifically to be these clones of our actual platform chain L1, this is all set up not for today only, but for tomorrow, for the 2x, 3x scale. So as you see Saga grow, it's not that the cracks will form. It is not that the stress begins to get put on the system, but the system, by definition, elastically scales with it and actually grows to accommodate and create more efficiencies the more adoption that we get.
I don't know why it's always like this, like where I explain something and I feel like I'm talking like, like a fish, and then you come in and I'm like, yes, that's exactly what I meant, but but it's let's say when when more and more people launch chainlets, right? Um, the economies of scales make it so that each individual chainlet can become cheaper. And when each chainlet can become cheaper, you can go out and convince more people to stand up more chainlets, and don't have essentially they're not forced to essentially try to put as much transactions on the chain. They can, maybe a college student can spin up a chainlet and use it as a place to experiment with some stuff that they're working on, kind of the same way that college students spin up AWS instances all the time, right? And when you do that, and when more people are putting in there, that's not maximally utilized, then your system essentially can accommodate more chainlets, and which then on average the cost of running these go down, which then you can make the price cheaper. So you see how the feedback loop here that we're designing is something that's very antithetical to everyone else who's designing systems in the blockchain space. In the blockchain space, usually what ends up happening, as mentioned earlier, is more people come in, it gets more expensive for everybody, and then it's like, and then you have friction, right? You're like, oh, okay, I don't want to build here anymore because everything is so expensive. As soon as you start flipping that economic design upside down, you start spiraling in the other direction, and you start getting into this rhythm essentially that doesn't exist today. And this is how essentially you build super scalable systems, not only in Web3 but in just kind of in Web2 in general. And so that's always what I've been really excited about in this space, is like, all of the kind of the efficiency gains that we can get from having more and more chainlets kind of come in that's more and more affordable, and then we can expand that out slowly over time, where maybe one day like running a chainlet or requesting a chainlet is like, $100 for a developer. And when you do that, then anyone can spin up as many chainlets as they want ultimately, and it becomes cheaper and cheaper for everyone together, right? So that's the package that we're trying to build. And I think Micah has done a much more eloquent job of describing what I was talking about. But I think that's what I'm actually really excited about with the economic design for Saga, at least. So